Yo, 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 this is Mr. O. What's up, Mr. O here, and today we're gonna learn how to evaluate, graph, and write a piecewise function. What is a piecewise function? Piecewise function are like multiple two or more functions that are built together, and they are separated by various domain or interval. Okay, what do we mean by that one? So imagine you have two or three functions, and you have to graph them on the same, but they are have their own respective interval. Like this function has to be graphed on the right side that are you know x greater than 0, one will be on this interval, one will be on the going to the infinity. So that's kind of thing. Okay, so let's go ahead now. So this is what it looks like. There are three functions here. um the a one major function is the a of x. Okay, but there are three function or expression are related here. One, two, three. Okay. This function here, the absolute value of x minus 8, is the interval is everything from the -6 to the less than or equal to that one. So x less than or equal to -6. So everything from -6, -7, -8, and so on to the infinity, we will use an absolute value of x minus 8. While 2x minus x squared is a quadratic, this function will be used everything between -6 to +1, including 1, not including -6, because -6 is already on the absolute value of x minus 8. While the other one is 4x plus 7 will be used everything from 1 to the right, everything greater than 1. Okay, so what do we do here? So first, in evaluating a piecewise function, let's look at this. Okay, a of -8, meaning say the x value is -8. Where does the -8 fall? On the first, second, third interval. So -8 is less than -6, right? It's somewhere here. So it should be less than -6. So we will plug in the -8 to this function here. So absolute value of -8 minus 8 will give us -16. Absolute value of -16 is 16. So therefore, a of -8 is equal to 16. Next, so a of 0. 0 is between -6 and +1. So it will fall on this interval. So you're going to plug in the 0 to this expression or that function there. So 2, 0 minus 0 squared. 2 times 0 is 0, minus 0 squared is still 0. So therefore, a of 0 is equal to 0. Okay, very good. Now, a of 4. 4 is greater than 1. So it will fall right here, x greater than 1. So we will plug in the 4 to the x here. So -4 times 4 plus 7. This will be -16 plus 7. It will become -9. So therefore, a of 4 is equal to -9. Next there will be a of -1/2. -1/2, again, that is between -6 and 1 here. So we will plug in a -1/2 right here and there. Again, you're allowed to use calculator here. You can just plug in, or if you would like to learn it manually, I can show it to you right here. So the very first thing you do, you multiply 2 and -1/2. This cross out, that will become -1. And then do not multiply this negative and negative there. That's wrong. Exponent first. What's -1/2 squared? Again, -1/2 squared means say -1/2 times -1/2, which will be -1 times -1 is +1. 2 times 2 is 4, so this becomes 1/4. But remember, there's a minus or negative outside, so this becomes -1/4. And combining the like terms, I need to have them same denominator. And for them to have the same denominator, I'm going to have a 4 here and multiply this by 4. This gives me I can erase this portion here now. This becomes -4 here. So this -4 minus 1 is -5/4. 4. And that's the answer. Okay. All right. There you go. That's how you evaluate a function. Okay. So one more to make sure that we understood what's going on here. I'm going to pause first. I would like you to pause first and try to answer this on your own for practice. Okay. All right, there you go. I hope you able to pause and try this on your own. Again, the answer here, I'm gonna go ahead now. F of 4. The 4 will be right here. Is x is less than or equal to 4. So means say I'm gonna plug in the 4 right there. So this will be square root of 4 plus 4. The answer is square of 8. Once we go to radical function and expression, we know that we can still simplify square of 8, which some of you probably put a decimal value, but here's how to give you an idea how to simplify it. 8 can be break down to 4 and 2, and 4 can be break down to 2 and 2. You look for a pair, that's 2 there, so the answer is 2 square root of 2. There are multiple ways of simplifying a radical, but that's one of the way I can show it to you now. But if you give me a square of 8 for now, I will accept it. If you give me a decimal value square of 8, I'll take it. But at the end of the year, you should all know how to simplify a radical. All right, let's move on. F of negative 5. Negative 5 is smaller than 4, negative 4. So x is less than negative 4. So I'm going to plug in negative 5 right here. So negative, negative 5. What's negative times negative? Is positive. So the answer here is 5. And f of 7, 7 is greater than 4. So the 7, we'll plug in this x here. 7 minus 5 squared. So 2 squared is going to be 4. There you have it. Very easy, right? That's how you evaluate a piecewise function. Let's move on now to graphing. Graphing, here you need to be very careful and particular to the given function. For now, since we're just starting, we will focus with constant and linear. And there are two functions on this problem, the 5x minus 2, which will be applicable when x is less than 1, x minus 7 when x is greater than or equal to 1. Okay, so the first thing we have to do here is we graph the 5x minus 2. Imagine that is same thing as y is equal to 5x minus 2, wherein the slope is the 5, the y-intercept is negative 2. So I'm going to start the y-intercept here, up 5 over 1. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1, or reverse 1, 2, 3, 4, 5, 1 left. So this orange line is basically the graph of 5x minus 2. But we will only follow the interval here. We will only accept as our answer based on the interval that if x is less than 1. 1 in the x value is right here, right? That's the 1 there. So I need everything from the left of from 1 to the left open circle. So means say I do not need everything on the right side. So I will erase this one here, erase it, erase it, erase it. Boom. And since that's open here, I'm going to make an open circle there. And that's the graph of the first function. And the next one here is x minus 7. So minus 7 is right here. That's the y-intercept. So again, y is equal to x minus 7. Let me do it again. X minus 7. The y-intercept is negative 7. The slope there is 1. So 1 up, 1 over, 1 up, 1 over, 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 and so on and so forth. So we know the graph will be something like this. But we know the interval is everything from greater than or equal to 1. So I don't need the entire line. So I'm probably going to need only from 1 to the right. 1 is right here. So everything on this side to the right only. And you may erase this one. We don't need that one. And that's solid because it's equal to 1. So this will be solid there. Okay. So let's identify the domain and range here. Okay. So for the domain here, we have a graph that is, this is, remember for domain, we look from left to right. This orange graph here, I know it looks like it's going down, but it's really going left side. It's tilted, it's going to the left side. And this green graph here is going to the right side. So it covers everything on the left and on the right side. It covers all numbers from the going to negative infinity and positive infinity. So the domain here is from negative infinity to positive infinity, or you can say all real numbers. For the domain, remember from left to right. While the domain here, you have to do it for as a whole. And the domain here, the range here, you look down going up, right? So this one here is going down, so it covers the negative infinity, and this portion here is going up, and that covers everything. So that is from negative infinity to positive infinity for all real numbers also. Okay, but let's change it. Let's make it more specific here. When you write the domain and range here, I need you to write domain range for each graph, okay? For each graph here, okay? So let's go first with the orange one, okay? The orange one. For the orange one here, the domain for the orange one here, let's just write on the side, okay? The domain for the orange side here is whatever the restriction based on the problem. The domain there is x less than 1. Or we can say that from negative infinity to 1 open. Its range here, look at the orange graph. The range is going down, right? You look at from the bottom to top. So the bottom there is negative infinity, and the highest portion there it's positive 3. Where the positive 3 came from? Because it's the highest point there, right? So it means say the range here is y is less than 3 because it's open. If it's closed, I'm going to put an equal sign here from negative infinity to 3 open. For the domain here for the green graph, the domain is again whatever the restriction right here. So the domain here is x is greater than equal to 1, or we can say from bracket 1 because it's closed going up, going to the right infinity. While the range here, you look at from the lowest one. What's the lowest point here? The lowest point of the green one is negative 6, and it's going up. So y is greater than or equal to negative 6, or you can say bracket negative 6 to the infinity. Okay, that's how you put the domain range for each of them. I would ask you to do it for every graph, not for the whole thing, because most of the time it will be all real numbers. So we will do it this way when we find the domain range. Okay, one more. All right, so we have this time we have three functions: negative 6, negative x minus 3, and x minus 1. And they have their own interval there, okay? So first, how do we graph y is equal to negative 6? That's the first one there. Y equals negative 6 is just, there's no x here. That means this x there has a 0x. The slope there is 0. So it becomes negative 6. So it's going to be just a horizontal line. But do we need the entire graph? No, we do not need the entire graph. We only need everything from x that are less than negative 3. Negative 3 is right here on the x, right here. So I need only this one here, but it's going to be open to the left. So I can erase this portion, and we don't need this one here. Okay, that's the first graph there. Okay, the next one there will be negative x minus 3. That is a line that y is equal to negative x minus 3. So negative 3 is right here. Negative x is slope there is negative 1. So down 1, right 1, down 1, right 1, down 1, right 1. Or you can go up 1, left 1, up 1, left 1, up 1, left 1. I would not make any more points on this side because as I look at the interval, everything from negative 3 to 2. Negative 3 is right here, up to positive 2 right there. So I don't need this last point here. So my graph will be like this, like a segment. Although this one here is closed, so this will be closed here. This open, so it will be an open circle right there. Okay. And for the orange one here, x minus 1. So you start at, that is same thing as y is equal to x minus 1. So you start at negative 1 here. And the slope there is 1. So 1 up, 1 over, 1 up, 1 over, 1 up, 1 over to the right. keep going, keep going, keep going. And I know the interval is x greater than or equal to 2, so everything from 2 here to the right, so everything just right here, arrowheads. So I can erase these 2 points there. That's close, so this will be close there. There you go. And that is the graph of this piecewise function. Okay, let's find the domain range here now. For the domain here, this is going left to right. The domain, there's a graph go to negative infinity, but it's stopped right here at -3. So the domain here is x less than -3, or you can say from negative infinity to -3 parenthesis. And the range here, it doesn't go up or down. It remains the same at -6. So y is equal to -6. If you notice here, this domain here is exactly the same thing as our interval right here. So that's the key. Just copy the interval from the function, okay? So for the red graph here, I know the domain is whatever is this one here. So I can just write it down, -3 less than or equal to x less than 2. Or you can say that one as bracket -3 comma 2 parentheses. The range here is the lowest point. The lowest point is -5. The highest point there is 0. So that means it's from -5 less than equal to y because it's range. No, I'm wrong there. It has to be less than only no. Okay, there you go. One more time. From -5 open, so y less than or equal to close 0. Or we say that from parenthesis of -5, 0 bracket. For the range there, for the orange one, look from left to right, it starts at 2 going to the right. So the domain there is x greater than or equal to 2, or it's pretty much the same, exactly the same thing as the interval there. The range here, range not b, the range here is the lowest point is from 1 going up, so y greater than or equal to 1. Or we can say here that it's from 1 bracket to the infinity. And this one here is from 2 bracket to the infinity parenthesis. All right, there you go. And that's how you graph piecewise function. Okay. Let me give you one more here, but this time you have to write the function. Okay, you have to do it on your own. This is kind of high level thinking skill question, but I'd like to give it to you. Um, let's do it portion by portion. You see this graph here? Let's say here's f of x. So basically here, you're given a graph, you're gonna write your function, okay? So the first one here is this one on the left. That is a straight horizontal line. So there's no movement going up or down, so you know it's a constant. And that number is -4. So that's what give us -4. If that is true from -2 to the left, so that means from x less than, it's open, so it's less than only -2. Okay, that's all you have to do there. Okay, the next one there is the middle one, the brown one here. Okay, this one here is a line that has a y-intercept. That's the y-intercept there. So the y-intercept, remember the y equals mx plus b. The b is the y-intercept. That is happen to be +1 there. The slope, you know, it's like from here to go there and left one. It's one up one, -1 goes to the left. So the slope there is -1. So -1x. Okay. But we're not going to write the entire equation. We're going to write this portion of the equation. So it will become -x plus 1. And that's only true from left to right, from -2 up to +4. In the -2 there, it's closed, and for the +4, it's open. So it will be from -2, close, and open for the +4. Okay? Now for the range, for the third equation here, we don't need that one. This what we have, this blue one here. Okay? Okay? So that is a straight line. Okay, let's find the slope first. This is the point, and let's find this point here. So 1 up, 1 over. So you know it's 1, 1. So you know this is gonna be y equals 1x. You know, if it's go up 1, right 1, it's the same thing as go down 1, left 1. down one, left one, down one, left one, down one, left one. Why am I doing this one here? Because I need to find the y-intercept. And in this case, the y-intercept is -2. So it becomes 1x minus 2. And that's only true if, again, we don't need the entire thing there. We only need where it starts and where it's going to go or ends. It starts at 4 on the x and goes forward to the infinity. So that means x is greater than equal to 4. All right. There you have it. That's how you evaluate, graph, and write a piecewise function. I hope you learned something. As always, kaboom.